Hello, I'm Peter, and this is Chris from Applied Brain Research. So AI began with the brain, and now it's going back to. Ourselves and companies like Intel and others are building neuromorphic technology to run AI faster and to enable more networks integrated to deliver higher order behaviors. AI is exploding. Edge devices in particular are absolutely, really exploding. There's projections of over 3 billion devices joining the network a year by 2025. They need computing, and they're throwing off an awful lot of data we would like to use to make our world more intelligent. Chris has been studying the brain at the University of Waterloo for over 20 years and has built the world's leading neuromorphic brain simulation system, which is now being merged with chips in development by ourselves and Intel.
We need new neuromorphic hardware in order to compute the way the brain does. Doing things like using spikes to communicate. We can design the neurons right into the hardware to make it more efficient, take advantage of the kinds of efficiencies that brains have. Your brain computes with only 20 watts of power. This will allow us to build much more parallel systems and introduce new features like on-the-fly learning, allowing the system to actually fix itself, improve itself while it's performing an action. If we bring all of these things together, we can begin to build real-time, low-power, and integrated neural networks. And this is exactly what ABR is focused on. On the hardware side, we're already shipping FPGAs. We've also been working very closely with Intel using their brand new research chip called Loihi, which is the first very effective neuromorphic chip. So we've built all of the sort of first demos and so on this. And we're really excited to announce today that by 2021, we'll have our own ASIC. On the software side, we actually have a very mature software environment called Nengo. This allows us to build brains, not just single networks, but integrated systems which have many different kinds of networks interacting. We can target those to many different kinds of hardware, not only neuromorphics, but also CPUs and GPUs in order to allow development and accelerate development. It's been built from the ground up to really focus on real-time dynamic AI. So it's perfect for processing real-time information like voice, video, control, all the way up to cognition. Here's some data. So we recently put a deep neural network on the Loihi chip using our software, and it's 110 times more efficient than a GPU. And it's even 5 times more efficient than their special purpose edge computing device, Movidius. Even more exciting is when we scale this up. So taking a network and growing it by 50 times, we see that on the neuromorphic hardware, we only have a 30% increase in power, in contrast to Movidius, which has an over 5 times increase in power. This is an example of running this kind of neuromorphic system. This is doing keyword spotting. You can see the spikes there that I mentioned before. So it's really working in the way that the brain does. Another example is this one. So typical robotics are actually dangerous to interact with because they use something called position control. If we make them safer to interact with using force control, the kind of control that all biological bodies move, then we can run into problems when they interact with systems in the world which they haven't had much experience with. But with this adaptive controller, it will actually learn over time to change itself in order to effectively deal with unexpected perturbations in the environment. So in short, this means that it can improve itself while working with a changing environment. Looking into the future, as Pete mentioned, we have a lot of experience building large models. This is the world's largest functional brain model that we've built using these neuromorphic principles. It's called SPAWN. It has 6 million neurons, 20 billion connections, and it does all kinds of different tasks, including perception, cognitive decision-making, and motor control.
So today, ABR is developing applications for corporates, and we do a lot of algorithmic AI research as well for military, advancing the functionality of edge AI. Drones that are visual, but also control their own flight paths based on the visual for infrastructural inspection. These are some of the leading edge integrated network applications we're building. So we sell 3 things. Developers who want to come on board now and go to nengo.ai, download Nengo, and start learning how to build integrated real-time dynamic spiking systems like the brain, applications for corporate customers, as well as paid research. So we've got the leading team with the most years in, the most mature software stack for neuromorphic technology, and the best solution on the numbers now for edge AI. And all of this works like the brains do. There's lots more to take from the brain. We're beginning, but that revolution has now finally begun. It's time to stop using CPUs and GPUs, which were designed for other purposes, and computing directly on the neurons the way the brain does, and we're seeing the efficiencies and the algorithmic advancements today with these technologies. Thank you very much.
Please come visit us at our booth.